Tepui means house of the gods, and these are elevated tabletop platforms. Tepui are isolated ecosystems because they're so high up, they can have plant and animal species that exist only in single locations. Good morning, good afternoon, good evening, and good night whenever you're listening to this podcast. We are the core of everything, and we're delighted to be back into your listenership. My name is Mark, and I'm here with Jack. Happy New Year, Jack.
Happy New Year, Mark. Did you have a nice time?
I did. Can I share a Christmas present that I got?
Yeah.
I got 2 rocks.
Did you actually?
I did. And the enjoyable part is the person who gave them to me then asked me about them, knowing where they came from. A little kind of geology test over Christmas, which I semi-passed.
So you got gold and frankincense.
And my myrrh.
Today we're going to be looking at mountains, lofty landscapes, as Mark aptly named the episode. Before we do, I just want to give a shout out to Christoph Schörner in Stockholm, who got in touch about our caves episode and said he really enjoyed it and wanted to keep interrupting because he knows a little bit about caves. And he also gave me a insightful way of distinguishing between a stalactite and a stalagmite.
Oh, go on then.
And he said he learnt this at school. It's if stalagmites crawl up your legs, you'd want to pull your stalactites down.
Nice. That's really good.
So stalactites come down
I love that.
off the ceiling.
Thanks, Christoph.
So thanks, Christoph.
I've also got a shout out to share off the back of the Caves episode, and that is that one of our regular listeners actually messaged in and asked whether the London Underground is the largest man-made cave. This is a slight diversion from our kind of more natural geological roots, but it's a good question.
Well, there'll be some mines out there that'll be much bigger.
I guess.
And I can imagine
by length or area.
Do you have an answer?
No, I don't. What I do know is that the London Underground is actually slightly more overground than underground. So I think it's like 51% overground, 49%
Is
underground. Yeah.
Is that because there's one line that makes it that's basically overground?
Well, I guess like Piccadilly, far out,
yeah.
districts overground quite a lot as well. Anyway, Spoiler alert for this episode, we're going to be questioning whether Everest is really the tallest mountain on Earth. So, lofty landscapes, here we come. So we're going to launch in and we're going to talk about a particular type of lofty landscape, and these are the tepui. Now, tepui in a local Venezuelan dialect, Pemon, it means house of the gods. And these are kind of like mesa sort of mountains in South Africa's. Mesas are kind of like these elevated tabletop platforms. And in South America, there's about 60 of them. They basically are these just big blocks of rock sticking out of the landscape. I'd really recommend Googling them to get an idea of what these look like. Tepui, that's Tepui. And they have like sheer walls on the side, sheer drops of like up to 1 kilometre. And because these things stick out so high, they can have lots of cave systems within them. So one of the largest caves on these tepui is 670 metres deep. And what's particularly interesting about them, which we'll talk a little bit more about shortly, is that these are isolated ecosystems because they're so high up. They can have endemic plant and animal species. So these are species that exist only in single locations. But we'll get onto that a little bit later. Most of these platforms are what we call as Precambrian age. So they're more than 500 million years old, and they're made from quartz arenite sandstone.
Yeah, and on that, so if we can talk about the formation of Tepui, there's like a specific mountain that I'm going to focus on, which is the tallest, which I can't remember the name of for the life of me.
Is it Mount Roraima?
Yes, exactly. Mount Roraima. Say that again.
Mount Roraima.
That one.
Or Roraima.
Exactly that one. So people have seen these sort of tabletop mountains or table mountains where you have really like vertical walls and then a really flat top. Now, that mountain that you just said, Roraima, is composed of, as you said, a quartz arenite sandstone, and it formed in the Precambrian era. So we're looking at 1.8 billion years ago it started to form. Wow. So this is a long time ago. And actually within these sandstones, we have evidence of dunes. So if you imagine the current day, the Sahara Desert, let's say, if that rock were to be preserved, you'd have the preservation of those sand dunes, and that's referred to as cross-bedding in the rocks. So these are 1.8 billion year old, or at least a billion year old sand dunes you can see that have been preserved, which is quite remarkable. Anyway, during the formation of Gondwana, the supercontinent, about 1.8 billion years ago, you had layers of igneous rock that were laid down, which are referred to as the granite. On top of that, you have this plateau of sandstone that deposited on top. So this region, Tepui, you have this sandstone plateau of the igneous rock. Now, about 180 million years ago, there was a tectonic uplift, and the sandstone plateau was broken apart by erosion, forming isolated mountain tops. It's like ice breaking apart. You have these sort of pockets of islands, basically, and these isolated mountain tops are known as these tepuis.
So we've got about 60 of these tepuis in South America, and the total surface area that they cover is 5,000 kilometers squared. So the areas on top of these tepuis is massive. So 5,000 kilometers squared, for context, is about 3 times the area of Greater London, or about the same area as Trinidad and Tobago.
Yeah.
While I was Googling that, I got lost down an interesting Wikipedia hole, which in this list of land areas, there was also a percentage of the country or kind of principality is water. And the highest one on that list is Clipperton Island, which is off the west coast of Mexico. And it's a French-owned atoll. So these atolls are like basically islands made of coral reefs. And 2/3 of the area of this kind of region or principality is water. Because basically what it is it's a rim of land.
Oh,
and
I
a
see.
lagoon in
and
the middle.
Yeah, okay.
Which is wild.
God, that sounds like a bounty advert. Speaking of tabletop mountains and those sort of things, there is Table Mountain in South Africa. For anyone that has been to South Africa, they've gone to Cape Town, you can see this big, high, flat mountain. And it's similar in appearance to these tepuis, but actually it's slightly different in the sense that how it formed is different. We still have this hard sandstone or quartz-rich sandstone, like a quartzite, and that was laid down in the Cambrian to Silurian era, which is 500 million years to, 400 million years ago? Something like that. And that's deposited on top of shale.
Which is like a kind of muddy rock or made from very small particles.
Yeah. And then after the deposition of the sandstone, we had these igneous intrusions, so magma rising through the crust, and as it rose through the crust, it solidified, formed granite, and that basically acts as like it's helped strengthen this sandstone that was deposited. Now, in South Africa, this tectonics after the Silurian compressed all the rocks together and folded the landscape. So imagine if you had Play-Doh and you squeezed it together, you form this like folded layer. It's like, we've used this analogy before, like a curly-whirly or something like that, right? Where you'll have these series of peaks and troughs and you push something together and squeeze it together. Now, Table Mountain, although it's massively in the horizon now, it's this big rising mountain. At the time, whenever all these things got pushed together, it was actually in the trough, in one of those troughs. And either side of the trough, you had these big mountains.
Yeah.
Over time, what's happened is that all the mountains either side have been eroded away, and what's left is the preservation of this hard sandstone.
Wow.
So actually, you're looking at a mountain today, but hundreds of millions of years ago, that was the valley.
Yeah.
Either side, you had big mountains.
Wow.
So can you imagine the landscape back then would have been
amazing.
Incredible, wouldn't it? It would have been ginormous.
So similar to that tabletop mountain, we also have this, loads of examples of these tepui, and one of them is called Mount Roraima, which is actually where the borders of Brazil, Venezuela, and Guyana meet on top of it. And they're always finding new species on these tepui because they're such isolated ecosystems. Like, if you've got 1,000-meter sheer drop on all sides, it's quite hard for a little ant or a beetle to climb to the top, and it's hard for things to get down. So you don't get much mixing of species. So even as recently as 2022, they discovered the tepui swift, which was a new bird, and this was published in the Journal of Ornithology. But yeah, because these basically ecological islands, and they kind of have their own unique climates because they're at such high elevations as well, between 1 and 3 kilometers, and actually about 60% of vascular plants, so these are kind of things like ferns, flowers, conifers, and also...
Vascular?
Vascular.
Like the gym and stuff like...
Presumably it's related.
Oh, hang on. There's a joke there. There's a joke somewhere there, isn't there?
Should I let you ponder on it?
Come back. Yeah, go on.
Raise your hand when you got it.
I won't be listening for the next 30 seconds, but carry on.
And 87% of frogs on these tepui are endemic, meaning they come from these places. And actually, things are so...
Shredded wheat.
Yeah.
Like vascular
Yeah.
plant, isn't it? Sorry.
Nice.
Carry on.
So these Tepui actually gave rise to Arthur Conan Doyle's book called The Lost World, which was all about these surviving dinosaur populations that we didn't know about just because they're in such isolated ecosystems. And it was originally thought, this led to or gave the name to the Lost World hypothesis, where these species we find on the Tepui came from ancient lineages. So if you find a certain frog, it's been there the whole time. It's not changed. It's always been there. But this has actually been challenged recently in a paper by Patricia Salerno and co-authors from the US, Ecuador and Venezuela. This was published in 2012. And they were saying that rather than having one species that's been in there since ancient times, that actually there has been more recent diversification of these species, and that they actually come from a common ancestor on the order of 2 to 5 million years ago. And they were looking at something called the Tepui hyla, which were a type of tree frog. And so they start to kind of discuss some of the hypotheses of how this could happen, whether one of them is the island hopping hypothesis. So things like birds can get between these Tepui more easily, plants as well, maybe insects carried by the birds. Harder for the tree frogs to, I imagine they can't jump between the Tepui.
Jump tables.
But it's a huge kind of finding for for biosciences to find that actually these worlds aren't so isolated, and a story of evolution there as well.
It reminds me of the thing that you told me in our episode about the pupfish. And you was that our caves episode?
Yes, I think
about the pupfish, and how you talked about how birds might have dropped something into the cave, which helped the evolution of say the pupfish, which is just isolated species within this one cave in Death Valley.
Yeah, absolutely.
And I just wonder if birds themselves doing exactly that can form these species on different tabletops.
Yeah. But you wonder, I mean, presumably humans might have some role in this as well. So Mount Roraima, they really manage tourism, and they let 200 climbers go up a month. But, if you've got a little, I don't know, frog in your bag and it gets to the top with its mate.
Yeah.
It's an interesting question.
Speaking of climbing then, so we want to talk a little bit about Everest, because we are talking about lofty landscapes and...
the loftiest of landscapes.
The loftiest of... Yeah. Well, this is the question, isn't it?
I wonder whether, as you're listening now, can you think of why it might not be the tallest? Can you predict what we're going to say?
Well, I guess we can't really wait.
If you want to play that game, you can pause the podcast, you can have a think, and then press play when you're ready.
They're busy people.
They are, yeah.
Yeah.
And we're grateful for their time.
All 15 of them. Yes, so we're talking about is Everest the tallest mountain on the earth? And actually, so funny this comes up because I was in Nando's last week chatting with some mates, and we started talking about how do you measure mountains? How is Everest known as the tallest? I think the problem is there's a distinction between the highest and the tallest. Before we do that, do you want to talk a little bit about Mount Chimborazo?
Yeah, well, so I'll start off by saying that Mount Everest is 8,848 metres above sea level. That's how that's defined. But Mount Chimborazo is a mountain in Ecuador. In the local dialect, it means snow on the other side. Now, this mountain is only 6,268 metres tall, so about 2 kilometres less tall. But because Ecuador is so close to the equator, Mount Chimborazo is actually the furthest point on Earth that you can get from the Earth's core. And this is because of something called the centrifugal bulge. So a bit like a spinning top, as the Earth spins, it kind of throws out its weight around its waist, around the equator. And so you get a bulge at the equator, meaning that your poles, so your North Pole and your South Pole, are actually closer to the Earth's core than the bits around the equator. So if you climb to the top of Mount Chimborazo, you are the closest you can be to the stars.
Literally speaking, rather than metaphorically.
Literally, yeah.
If you go to Hollywood Boulevard and stuff, I think you're pretty close to some stars. But... So essentially, this is the point. So this is a point furthest from the core and closer to the stars.
So that distance is the longest, and it's an inactive composite volcano. Last erupted in around 500 AD.
But from a literal point of sea level, it's 2,500 kilometres smaller.
Yes. Yeah. Absolutely.
So it's actually quite significant.
So the bulge is significant, really. Quite a fun little fact about the mountain is that people do ice mining on it, or they used to. And there's one guy there's been various documentaries and articles written about him called Baltazar Uskar. He's 70 years old, I think, now. And he used to climb this mountain once a week since he was 15. And he is the last hilero, which translates as Iceman. And he would go up the mountain and mine ice that he would then bring down and sell in the market that they would use in ice cream or fruit juices. And he's become famous. He's met the president of Ecuador. He's been flown out to New York for these documentaries. And actually, over time, his walk is getting longer. As climate change kind of makes the glaciers recede, he has to go further to get this ice. But he also carries 2 30-kilogram blocks of ice on his back.
Wow.
And he's only 1.5 metres tall.
So Everest is known as being the highest mountain.
Mm-hmm.
Right. So, as you said, 8,848 metres. But there's actually a difference between highest and tallest. So when we're referring to the highest, which is Everest, which is 8,848 metres high, we're talking about its relative to sea level. Mm-hmm. But the tallest is the distance from the top of the mountain to the base, and this could sometimes be underwater. Mm. So obviously the highest mountain is Mount Everest, but the tallest is Mauna Kea, which is 10,210 metres, so just over 10 kilometres. So it's taller by a kilometre and a half, 1.4 kilometres.
Yeah.
And the formation of Mauna Kea. So normally what happens is, and this is the case of Everest, 2 plates. So if Everest, it's the Indian plate and the Eurasian plate, both continental plates. They have a similar density, and they move together and they smash together, and that causes uplift, which is why Everest is still growing today, and that's why the Himalayan mountains formed. But sometimes what happens is, not even close to these plate boundaries, you have in the centre of a plate, you might have a hot spot, which is basically this anomalously hot zone in the mantle, which is hotter compared to the surrounding mantle. Mm-hmm. So as the plate passes over the mantle where this hot spot is, mantle rises up and extrudes as lava. And this builds volcanic islands.
So you get like a little plume of material coming up
through the crust. Now, as the plate moves over the hot spot, essentially what happens is a volcano forms, but as it passes over the hot spot, it becomes inactive. Mm. But you get this chain of volcanic islands, and that's what Hawaii is. So Mauna Kea started to form as recently as 0.8 million years ago.
Wow, 800,000 years.
800,000 years ago. And since then, we've had obviously layers upon layers of igneous rock that form, which create this massive mountain.
And then at some point, so that plate is moving, and where Mauna Kea is at the moment, that won't be over the hot spot, so that will go extinct. But then the bit on the plate that's moved over the hotspot will then start to form a new volcano?
Yeah, so I mean, there actually are new volcanoes starting to form, but obviously they're still under the ocean, so we can't see them yet. Okay, but there are fresh new islands forming in Hawaii.
Seamounts, those are called, I think.
Seamounts, yeah.
So maybe that's thrown into question a little bit what our tallest or highest or most bulging mountain is. But that's just on Earth, isn't it?
Yeah, exactly. So we're talking now about the tallest mountain in our solar system, because what's been noted as the tallest is Olympus Mons on Mars.
For the record, this wasn't Mark who wanted to bring in the planetary science here. This was all Jack.
Well, yeah, but I felt like there was something missing from the episode.
There always is.
Yeah, exactly. Now, I say tallest mountain because Mars doesn't have an ocean.
Right, so you can't do it relative to sea level.
Yeah.
Nice, yeah.
Yeah. Being a bit pedantic there.
Good technical language.
So Olympus Mons is 21.9 kilometres tall from base to peak, which is double the size of Mauna Kea.
Wow.
It's a shield volcano. So I'm pretty sure Mauna Kea is also a shield volcano. It's the idea that basically lava comes up and it extrudes on the surface and forms these very, very shallow slopes of lava either side of the centre, and a small little peak. And these thousands of layers of basalt mean that the rock is basically much wider than it is tall. And in fact, this Olympus Mons is the width of Poland.
Oh.
It's wider than the base of Everest and Mauna Kea combined.
Whoa.
So this is huge.
Just blows things out of proportion. Really.
obviously quite difficult to measure because we're obviously looking at satellite images. And actually now maybe I don't know if there's a drone
Yeah, I'm not sure how close the rovers are.
A rover's gone round the base of it and measured it with a stick.
I imagine that engineering, that would be quite difficult to get it to climb up the mountain.
But you can do the base of it and just go around the base.
Yeah,
but
string.
Obviously it's quite difficult to measure. There is also a crater in the peak of a crater of the Vesta asteroid. It's called the Riasilvia Peak.
Is this like a central peak of an impact crater?
Yeah. And this is possibly taller, and it's estimated to be 22.5 kilometres tall.
That must be quite a large proportion of the diameter of Vesta. Vesta's quite big, but not as big as Mars.
How does a peak form in the centre of a crater?
It's a bit like when you drop a rock into some water, and it kind of goes plop, and when that plop finishes, a little bit of water comes back up in the middle, and that's it's the rock rebounding and forming that central peak.
Okay. So maybe it's still rising then. Maybe that plop still hasn't finished plopping.
With that, we will end our Lofty Landscapes episode. Thank you so much for joining us and listening. If you've got any thoughts, questions, queries, problems, doubts, please do get in touch.
You say career problems?
No, questions, queries, problems, doubts, but also career problems. We are not trained career advisors, but we will happily chat to you.
Give it a go. Career problems.
Thank you very much, and we'll see you next time.
Bye.